Let's do section 10.5, page 528, exercise 33, which reads, explain how to rearrange the terms of the series from the specified exercise to form A, a divergent series, and B, a series that converges to 4. And the series we're to consider is n equals 1 to infinity of negative 1 to the n plus 1 times 1 plus n over n squared. The idea is to group the positive and negative terms in such a way that we create the series that we are supposed to create in part A, which is a divergent one, and then create what we're asked to do in part B, which is a series that converges to 4. So if we're going to be considering the positive and negative terms separately, maybe we should write a few of them down. So the first positive term we're going to get is going to be 2 over 1 squared. And then we're going to have 4 over 3 squared plus 6 over 5 squared. And if we start our numbering again so that this is the n equals 0 term and this is the n equals 1 term, etc., then our general term is going to be 2n plus 2 over 2n plus 1 squared, and that will continue. And then our first negative term is negative 3 over 2 squared. And then we have negative 5 over 4 squared. And then we have negative 7 over 6 squared. And again, if we start renumbering our n values, so this is n equals 0 and this is n equals 1, our general term is going to be 2n plus 1 over 2n squared, and that will continue. Now on their own, both of these series diverge. The positive terms go to positive infinity and the negative terms go to negative infinity. But we are supposed to look at a combination of them. And for part A, we're supposed to find a divergent series. So for instance, we could add up a bunch of positive terms until the partial sum was greater than 2. And then we could add more partial terms, negative terms in this case, so that our partial sum, and I'm just going to give it a new index here of m, would be less than negative 2. And then we're going to add more positive terms until our next partial sum is going to be, say, greater than 4. And our next partial sum after we add negative terms will be less than negative 4. Now you should remember that in the limit as n goes to infinity, the nth order partial sum should be equal to a number. That limit should be equal to a number if our series converges. And in this case, we just keep swinging back and forth between positive and negative sums, and we do not, in fact, converge on a number, so this is going to be a divergent series. Now, in part B, we want a series that converges to 4. So for instance, we could add up a whole bunch of positive terms until the partial sum was a little bit greater than 4. And then we could add some negative terms until the partial sum was a little bit less than 4. We add some more positive terms until our partial sum is a little bit greater than 4, not as much as before. And we add some more negative terms until our partial sum is just a little bit less than 4. And as we keep repeating this, we're going to be closing in at 4. So in this case, when we take that limit as n goes to infinity of the nth order partial sum, that is in fact going to be equal to 4 because that's the value that we are literally converging to.